Our last speaker of the day is Natarajan Chakrapani, and he works on ETLs at Optimizely, which is the same company that Nick works at, which is the other person that helps organize SF Python. So huge shout out to Optimizely, which has been really amazing and great friend of the community. So today, Natarajan is going to be speaking about using Airflow to automate ETLs. All right, so without further ado, final round of applause for Natarajan.
So yeah, thanks for the introduction. So my name is Natarajan, and I've been at Optimizely for 5 years, and I love data pipelines. And we are part of still a very small team, like 2 or 3 data engineers, and we build data pipelines at Optimizely. So we started using Airflow since last year, and prior to that, we used a variety of solutions, and I'm very excited to tell you more about Airflow and how it has really helped us. So to begin with, what Airflow is basically a way to schedule, monitor, and author workflows. So it's like any ETL. So let's say you have you want to pull data from somewhere, like do some transformation and load it into a database. That's a workflow. So that's like a typical ETL workflow, right? So Airflow allows you to actually write these workflows in the form of directed acyclic graphs. I'll get to that in a bit. And the origins of Airflow, it was originally open sourced by Airbnb, and now it is an Apache project. So that's a lot of street cred. And previous similar projects that tried to tackle this workflow problem that I've used personally were like Luigi, that was from Spotify. It did not have any inbuilt triggering, which was a bummer. And then prior to that, I used Uzi, which is very popular in the Hadoop world, but it uses XML, so it's 2018. We should not be using XML. And prior to that, we used actually Jenkins to make ETL pipelines, which was like horrible. So thanks for Airflow. So why do we use Airflow? So the main thing I really like about it is we can store the configuration as code. And as soon as you store configuration as code, you can version control it. And you can decouple the execution from the workflow, the actual workflow. It has a great UI to like see how your DAGs are performing. You can centralize all your configuration. You can do a lot of resource pooling. And there are third-party integrations that really extend the functionality of Airflow. You can also forget about task parallelization in your code itself and let your workflow take care of parallelization. So I'll give you a small demo as we go along. So just to give some more context, the way when we say what Airflow is basically it's a supercharged cron, basically. So think of all your cron jobs, but better. So sorry. So think of the scheduler. So let's say you have all your workflows as basically Python files, and there is a scheduler process which will be running on your cluster. In this case, like our cluster is just like a one node EC2 instance. So we have a cron process, and there is a web server which powers the UI, and then all the tasks that the scheduler thinks, oh, this needs to run, is sent to Celery, which is a task queue worker. So you can spawn as many workers as you want, depending on the size of your cluster. And all the DAGs or the workflows, the metadata of that is written to like a relational database. You can set any relational database to point to it. So typically how it works is the scheduler is basically looking for any new DAG runs to run, and then it sends those tasks to the Celery task queue worker. The web UI is reading from the metadata database and showing up which DAGs are currently running, which have run in the past, and what has been the status of those runs. So to give some nomenclature, a DAG comprises of tasks, which are basically instantiations of various operators. So they are organized in some dependent order. So a small toy example is like this. This is like a DAG where task one, once it's complete, then task two starts, and then task three starts. So task is basically a process that the worker works on, and it is an instantiation of a Python operator. And then there could be a bash command that runs after this, and then finally maybe a Postgres operator which talks to a database. Right? So typically, the thing to understand is tasks typically don't communicate with each other. Airflow allows you to do that via something called as XCOM. You can pass in very simple key value attributes, but you should think of these tasks as idempotent operations, typically. So as soon as there is a workflow, it's perfect for an ETL paradigm. So in our case, we kind of do a slightly modified one. We do an extract, load, and transform. So we fetch data from various internal APIs. So let's say it could be Jira, it could be Salesforce, it could be so many internal systems that Optimizely uses. We fetch data on a periodic basis. We have like from the last sync time. We fetch the data, put it in S3, and then we load that data from S3 into some tables in our data warehouse, and then we do some transformation, like some stored procedures on Postgres itself, and that's our third step. So since all these tasks are really well defined and it's like a very easy workflow to follow, this like fits perfectly with the Airflow solution. So the things, as I said, to keep in mind, we have to keep the tasks idempotent. So one task could fail. It should not, you should be able to rerun the task because Airflow has built-in task retries, so you can allow tasks to be retried automatically. It also allows you to have alerts on failure, so you can send it to like PagerDuty or anything else. So there are already integrations built in. And you can also have SLA misses. So let's say your task should ideally take 5 minutes, but it's taking 2 hours. So Airflow can notify you that, oh, things are not going okay. So let's take a very like small example of what a DAG really looks like. So it's basically a Python file. You instantiate a DAG object, which tells you what the DAG ID will be and what the start time and the schedule interval would be. So the schedule interval is just a cron expression of how frequently this DAG will be scheduled. And the start date tells the scheduler from what time I should start running it. So in this case, the DAG will run at 10 a.m. UTC from August 13th, right? So the first task in the DAG is a Python operator, and we can call a function, some module function. So when this DAG runs, the first task will be this. And then let's say we add another new task. So this task is linked to the DAG because we can see at the end that there is a DAG attribute. So we can add as many tasks as we want and set the dependency where either a set upstream or a set downstream. So that establishes the dependency between the tasks. Some useful task arguments, like similar to the, just like the task ID and the Python callable attributes here, are retries. So you can set a default retry to say 2. So let's say you know that some stuff sometimes fails. You can let Airflow will automatically retry for you the specific task. You can also email on failure. So say a specific task is important enough that you should be notified on a failure. You can set that as an attribute. You can also set an on-failure callback. So let's say you notify a Slack channel, that's what we do, or say send it to PagerDuty. You can specify task executions to various pools in Celery to say that maybe some tasks are more important than the others, so you can do some prioritization based on that. You can also have trigger rules to say that when you should only execute task 2 if task 1 fails. So you can also do that. Typically, the default rule is that only when task 1 succeeds will a downstream task start executing. So you can modify with that. So instead of screenshots, I'll actually show you a live example. So, all right. So this is actually our production Airflow cluster. We have a bunch of DAGs running. So you can see that right at the outset, this beats any workflow tool hollow in terms of just the UI. It tells you very clearly what schedules each of the DAGs is running, the state of the recent tasks, and the previous DAG runs. So let's drill into one example. Let me take a very simple one. So this is our Jira ETL pipeline. So this is like fetching Jira tickets from our internal org. So this is our workflow. We check for whether we have a master switch to say whether our ETL should run or not. Say for some reason we don't want it to run. So once it succeeds, then we fetch like information from the Jira API. We stage it. we transform it, and at the end, we notify our Slack channel that everything is done. So just visually, you can kind of see the structure, and any newcomer is like at ease when they see this, right? So the cool thing is you can also look at the code right here, which is awesome. So most of our DAGs follow a similar paradigm of this view. So what we have done is we have templatized our DAGs. So we just specify in our code, we just say data source, and we have all our scripts already bundled. And we just say, just create a DAG for us, and it just creates it for us. So all this is rendered automatically for us, and the rendered code is actually here. So this may be too complicated right now, but essentially, we have helper methods to do the fetch, the stage, and the transform, and specific to each data source. So templatizing it is really, really useful. Right? This is not just for ETLs, but like as we heard a few talks on data science, like this has really good implications. Wherever there is a workflow, you can use Airflow for your needs. All right. So what happens? So this is the case when things succeed. So all these operators, you can see like they're highlighted here. We basically run a bunch of bash commands, which are like Docker commands that we are running here. And this command specifically is called a short circuit. So we are actually talking to our database to see whether this ETL should run or not. So this is like a simple paradigm for us. Other things so all this information about this task succeeding goes to the database. And you can see when stuff goes to a database, you can visualize it very well. So uh, Airflow gives this for free. You can see all the past DAG runs, the status of each task run. You can also see how long tasks have taken in the past. So look for spikes and see what happened that day. So this all comes out of the box. I've done nothing extra for this. And then some cool Gantt charts to tell you how long each task is taking. All right. So to see a more complicated. So this is the case where I'm just using like a simple workflow. We also have a few complicated workflows where you can trigger other DAGs from a single DAG. So let's say we take, so right now actually there are 3 DAGs running. So the ones highlighted in red, they show that they're running actually. So let's see, let's take this guy. All right, so actually it's running right now. So this is a slightly more complicated DAG where we are running a pig script on a Hadoop cluster, and we are also triggering other DAGs from this DAG. So you can do a lot of chaining, and my personal recommendation is to not have too many tasks in your DAGs. It just complicates things, but sometimes you need to. So this is an example of a more complicated DAG. So this is all pure Python code, and all this is rendered because of this, the code behind it. And you can also have nice documentation on your DAGs, which like this one. So anybody looking at a DAG can understand what the DAG is about. So it's very useful when a new person is looking at it. Right? So cool. So that was these. All right, so I went through this. So authoring a DAG is actually pretty simple. It's just you have to make sure that take care of the thing that your tasks need to be idempotent. As long as they're that, you should be good. You can also leverage Airflow variables. So it gives you, if you want to share things across DAGs, you can leverage variables. So we use variables at Optimizely for Airflow to differentiate between a dev and a prod Airflow cluster. So we dynamically set our schedules. So we don't want our DAGs to run at the same frequency in a dev cluster as compared to a prod cluster. So we use the variables accordingly. Cool. All right. So back here, so yeah, these are a few things I showed earlier. You can see the diagrams over time, and Airflow has a lot of, as I said, operators. So you can read the documentation. Bash operators are like very common, where you just want to run a bash command. Postgres operators, you can talk to a database using inbuilt connections. You can define a connection in Airflow and talk to various databases. Not just databases, you can also talk to like the Google Cloud. And so this is the extensibility aspect of Airflow that is really made it successful. So what happens when a DAG fails? So let's say this happens a lot. So let's say our cluster is misbehaving. So the DAG fails, and you kind of see a big red line here. So you can click on it, go to the view log, and see what happened there. And this log also goes to S3. You can configure it, and you can check out what really happened. And once, let's say, your thing is fixed, you can mark it as a success, or you can rerun it by clicking that. So this is all done through the UI. So I just wanted to touch about, okay, this is all nice and snazzy, but how does our DAG development really happen? So typically when we write new DAGs or update existing DAGs, as soon as we merge to our master branch, we have a Jenkins job, which listens on the push, tarballs that master branch to S3, and then we have a DAG on Airflow to sync this code back into Airflow. So we are using Airflow to sync itself. So this is our typical like DAG development cycle. So just to show you, uh, have a slide. So this is typically our DAG like code sync. So we fetch our code. This is coming from S3. We untar it on the cluster. We compile any recently changed stored procedures right there. So this is a Postgres operator. And then we sync the DAGs to the location where the cron or the scheduler is looking for. The scheduler looks at a very specific location for all the DAGs. So we need to make sure that the DAGs are at that place. And then we notify our Slack that this sync happened. So typically this happens like once a day as per this schedule, the top right. But whenever engineers want to commit code, they can also trigger this manually. So about testing, which is very important, DAGs as such don't need to be tested. We just need to make sure that the DAGs are syntactically correct. It is expected that each of your tasks individually are unit tested well. So there is no need to test the whole DAG since it is just a collection of your tasks, right? So we have a very simple, like a toy example. We just make sure that all the DAGs are like correct, they're compiling correctly. So we utilize the DAG bag model, which basically takes in all the DAGs and makes sure that it is valid Python code. So deploying is very important. So when you want to test, let's say you're writing a new DAG, you don't want to test it in production, you want to test it on a dev. So it's best to have like 2 Airflow clusters, one for dev and prod. And it also is very useful if you have like a bootstrap script or like a bash script to easily deploy any dependency. So Airflow automatically gives you a lot of base Python packages already, but if there is anything additional, you can do that. Or you can also use Docker in case to run your specific tasks. All right. So definitely leverage Airflow variables to maybe differentiate between your environments to set the schedule. And you can also sync, we also use the variables to sync specific branches to the dev cluster versus the prod cluster. So you can really hack around that. And then you can also utilize the Airflow connections to actually just configure connections within Airflow itself so that the Airflow task can directly talk to a database or to any like cloud provider like S3 also. So Airflow provides a lot of hooks to talk. So yeah, that is pretty much that's all I had. So definitely check out Airflow. It's the Apache open source project now. And yeah, feel free to email me with any questions.
All right. Thank you very much. Are there any questions? Wow.
Hi. My name is Daniel, and I work in company Nurantis, and my question is about bash operators. So why do you need a bash operators if you already have Python in your project?
Oh yeah, so that's a good question. So sometimes you you want to call a certain method in Python, so you use a Python operator then. But like say there are specific binaries for which there is no Python alternative. So sometimes like it's like a 7-zip or something. So you want to run a bash command. So you just want to utilize the workers bash command to say okay like sudo unzip something, right? So like when we are let's say syncing code from S3, you want to put it in a specific location. So maybe instead of using Python, if you're more comfortable, you can use a bash command. So there is no strong reason to use either, but depends on your comfort. So both options are available.
Okay, so if I would like to implement all anything in Python,
You can repeat it. Yeah.
Can you repeat once?
Oh, sorry.
okay. So if I would like to implement all the logic on Python, then I may not use bash operators, right?
Yeah, so that's totally fine. Yeah, so it's totally up to you how you want to define it. So, oh yeah, sorry. The question was, is there any preference to specify a Python operator over a bash operator? Right? Yeah. So yeah, it totally depends on your workflow.
Um, my first question was answered by that because I was wondering if you have workflows where they're primarily bash operations entirely. But my main question is, what experience do you have in terms of scaling of this, in terms of heterogeneity of the tasks, the number of tasks, or the amount of data that they're managing? Kind of what's the scale that this has been tested at already?
Got it. So typically so by default, you can configure the number of workers. So if you're running a one node Airflow cluster, uh, so we run like a 32 gig machine, like EC2 instance. So we are okay with like 16 workers right now. And it totally depends on how many DAGs you're running in parallel. So you can also set at the DAG level how many active DAG runs you want. So let's say you have a DAG which is supposed to run from 10 days ago. Do you want 10 runs of that DAG like simultaneously? So you can really scale that. Yeah.
I was asking a slightly different question. How much has it been tested? What scale has it been tested? Like how big?
Oh.
What's the biggest number of DAGs
Yeah.
you've had?
Oh yeah, at what scale it has been tested? We run like about 100 DAGs right now, and we are okay with 16 workers in parallel. So it depends totally on how you're scheduling your DAGs. So if many of them run at the same time, then maybe 16 may not be enough to go. So if you have like a 32 gig RAM machine on EC2, I think 16 workers should be like more than enough. So it depends on a use case to use case, but like yeah.
Do you do heavy work on the workers? Like, do you run like pandas or something that does heavy work, or is all the work offloaded to something like Hadoop?
Yeah, so you can do heavy work on the workers. So it depends totally on like how your cluster is set up. There's nothing preventing you from doing that. But when we want to run Hadoop jobs, we actually send it like to a Hadoop cluster, so like through an API. So that's how we like offload it. So we just poll for the status and see whether it returns a success or not. But there is nothing preventing you from running like a huge unzip command on like a worker. Totally depends on the machine.
On deployment failures, how do you roll back, and how do you mitigate damage to whatever data you're touching?
Oh,
And-
so
yeah.
cool. Yeah, that's a good question. So when there is a deployment failure, so the interesting thing to note is Airflow is not actually transferring data from task to task. It is only doing like executing the workflow. So if there are any deployment failures, all the DAGs are at a single location. So you can easily roll back a DAG and like revert to a previous version of your DAG, like depending on how your DAGs are syncing. So you could do that.
Right. So if there's any issues with your jobs running, say populating pipe tables, and then you realize that it's messed up, how do you roll back and use the previous data, or is there no mechanism for that?
Yeah, so one quick way is to like just kill the workers first to say like stop doing what you're doing. So you can kill the workers, like the Celery has, you can see the UI on Flower. So the Celery workers are exposed on Flower. So Airflow allows you to do that. You can kill the workers immediately and then roll back your DAG and make sure that you can mark the running DAG as success manually on the Airflow interface itself. So like to prevent what it's doing.
Is there any notion of versioning the different segments of the DAG? Like, for instance, in my case, I'd be thinking of the workflow is actually generating a set of forecasts, and there's a sub DAG that I'd be running. I want to do a number of different scenarios there, and at the end of the day, I'd want to be able to, verify which inputs, which scenarios correspond to which sets of outputs farther down.
Yeah, so typically, you're running like multiple versions. So typically, you can have multiple DAGs and just like name it accordingly. But if doing it in the same DAG might not be a great idea because you can't see like previous versions of a DAG within a single DAG. It only shows you what the DAG state is at that point. So it's better to have multiple DAGs, like highlighting your various use cases.
Hi. So we're actually going through an Airflow, like we're trying to do a migration from Luigi to Airflow.
Awesome.
And yeah, I'm super excited. I hate Luigi. And so I've got two questions. So the first question is, what were your pain points in making for Optimizely making the transition over to Airflow? Like if there's like a few things that you could say like, hey, we ran into this issue while we were on this journey, don't do this. Like what would you say?
So definitely, very good question. So the first thing you do is make sure that when your DAGs get deployed, look at the core variables for Airflow and make sure that you don't accidentally start DAGs as soon as you deploy it. So there is a parameter called like max active runs equals 1, which makes sure that only one instance of your DAG is running at any point. So that's an important variable to keep in mind. And also remembering that the way the Airflow scheduling works is that the DAG only kicks in after the start date plus the frequency has elapsed. So that gets the people who start with Airflow a bit off base, because that's not very natural to assume. And the other thing is you have to make sure that if you have multiple DAGs in multiple repos, have a good deployment strategy to make sure that you have some way of syncing your DAGs from your repos to a common Airflow cluster. So just think through that initially. But otherwise, yeah, I think it should not be that complicated.
And then the second question is, we're right now our infrastructure, we've got like a Kubernetes cluster for a lot of our data engineering stuff. And so we're kind of already in the mindset of where we're thinking of using like Docker images for Airflow in order to make sure that we can easily do updates and all sorts of other great things. Has Optimizely experimented with containerized Airflow infrastructure, or are you just keeping it pseudo bare metal for the time?
Yeah, we're keeping it pseudo bare metal. So we want to allow various teams to spin up their own Airflow clusters as per their needs. Because right now we are just doing a single node setup. So that's sufficient right now for our needs. But yeah, a multi-node setup is something that we'll consider in the future.
Wow, so many great questions.
Thanks.
Thanks again. Let's give another round of applause.